Good afternoon, this is Stan Forrester for Indian River State College Physics, and we're talking about kinematics or motion in one dimension today. We'll also be talking a little bit about significant figures, but let's go ahead and get started. Okay, today, kinematics. Long way of saying motion. Okay, we'll talk about the causes of motion later, all right, but right now we're going to be talking about displacement, which is a distance in a particular direction. Average velocity, average speed, which is the magnitude of the velocity, sort of the velocity minus the direction, instantaneous velocity, and average and instantaneous acceleration. Okay, so instantaneous velocity is really what we mean when we talk about velocity. So we're going to just drop that terminology after today. Okay, we're going to develop these equations of motion under the conditions of constant acceleration. These equations are going to give us velocity and position at any given time. We're also going to talk about a special case, which is free fall motion. Okay, motion close to the surface of the Earth with a constant acceleration of 9.8 meters per second squared downward. Okay, finally, we're going to study graphic methods by which we can address motion under non-constant acceleration. Basically, we're just going to split the problem up into different sections, different periods of time in which you have constant acceleration. Okay, we'll get on to it with significant digits. Here's our rules. Okay, all non-zero digits are significant. All zeros between non-zero digits are significant. Any zero after the decimal point is assumed to be significant. Okay, examples. 3.1415 has 5 significant digits. We got 3, the 1, the 4, the 1, and the 5. There's 5 digits there. There's 5 significant digits. Okay, 7.004 and 6.203. They have 4 significant digits each. Okay, notice that there are intervening zeros in there, but they're between significant digits, non-zero digits, so they're assumed to be significant. Okay, 2.00 and 5.30 times 10 to the third each have 3 significant digits. Okay, so the second one is in scientific notation, but you'll notice that 5.3 and 5.30, mathematically those are exactly the same, but by putting that 0 at the end, we are signifying that that 0 is a significant digit. Okay. Propagation. When multiplying numbers, the final answer must be rounded to the same number of significant digits as the least significant input. Here's our example. Volume is length times width times height. Okay, we're going to throw some numbers in there. 3.14, 2.00, and 6.203. We just crunch those numbers out and we get 38.973449. Okay, our calculators are wonderful that way. They give us lots of digits. But our least significant input has 3 significant figures. So 1, 2, 3. So we're going to have to round this off to 3 significant figures. We take one look beyond that 9 to a 7. It's greater than 5. So we're going to have to round up. 3.89. Round it up. Well, 9 becomes a 0. It propagates. Well, 9 becomes 10. So we carry the 1. Okay, and then it becomes 39.0. Okay, we're back to kinematics or motion in one dimension. We're going to go ahead and continue. We need to talk a little bit about coordinate axes. Okay, your x-coordinate system, it's just a number line. It has a 0 on it. It has positive numbers to the right and negative numbers to the left. Wherever you are on that negative line, that number line, that describes your position. Okay, your x-coordinate can be positive or negative depending on where you're located on the x-axis. Displacement is the change in position between 2 different points or 2 different times. We could say, well, let's talk about motion at times. Okay, very often the coordinate will change with time. And so we use this delta notation. Delta means final minus initial. So delta x equals x sub 2 minus x sub 1. So example, x1 is 5 meters and x sub 2 is 12 meters. Then delta x, the displacement, is 12 minus 5, or 7 meters. The positive sign indicates that we're moving in the positive x direction. Let's swap it around a little bit. Okay, x1 is 5 meters and x2 is 1 meters. Then our displacement is 1 minus 5, or negative 4 meters. The negative sign, delta x sign, indicates that the motion is along the negative x direction. Okay, so let's consider the motion of an object from an initial position of 5 meters to x equals 200 meters, then back to 5 meters. The displacement is 0, okay, because your x2 is 5 meters, your x1 is 5 meters. 5 minus 5 is 0, your displacement is 0. Even though in between it moved out to positive 200 meters, okay, or let's see, initially it moved from 195 meters, and then it moved 195 meters back for a total distance of 390 meters. That is irrelevant. That is distance. We are talking about displacement. Okay, let's pause here, and we'll continue with part 2.